Hello, I'm Emma-Louise Coffey, and you're welcome to the Dairy Edge, the Teagasc Dairy podcast. We're bringing you the latest information, insights and opinion to improve dairy farm performance. On this week's episode, researcher Jonathan Herron quantifies the emissions agriculture and specifically dairy are contributing to total national emissions and explains how farmers' practices have reduced the intensity of emissions from milk production by 10%.
So in 2019, the agriculture sector contributed 34% of our national emissions. Within this then, the dairy cows specifically would contribute approximately 40% of that. So you're talking the dairy animals are contributing around 12% of our national emissions, and that's through enteric fermentation, manure management and manure grass.
And specifically, if we want to talk about the exact gases we're talking about here, we talk about CO2 equivalents in the overall greenhouse gas picture, but what exactly are we talking about in relation to dairying or agriculture?
Yeah, so the agriculture sector is unique in comparison to other sectors. So the likes of your energy and your transport sectors are dominated by CO2, and that's through the use of fossil fuels in those sectors. In the agriculture sector, it's dominated by methane and it's dominated by nitrous oxide. So methane actually makes up 60% of the agricultural sector's emissions. And over 90% of methane and nitrous oxide is emitted in the agriculture sector. So in terms of trying to mitigate emissions from the agriculture sector, methane and nitrous oxide are the gases we need to focus on.
And looking at that 12% of total national emissions coming from dairy, how exactly are you calculating this, Jonathan?
The way it's calculated in the national inventory is through the IPCC methodology. IPCC methodology. In Ireland, though, and what we do in Teagasc and research, we use a methodology called life cycle assessment. So it slightly deviates away from the IPCC methodology. So IPCC just looks at what happens on farms, so the on-farm activity and the on-farm emissions. In research, we apply life cycle assessment, which is an internationally standardized methodology that calculates the emissions of a product, a service, or a process from raw extraction of the materials up until it's disposed of. In agricultural life cycle assessments, we apply, it's most commonly applied a cradle to farm gate life cycle assessment, which means everything from the extraction raw materials up until the milk leaves your farm in the lorry. And the reason we apply that system boundary is that it allows us to identify areas within the farm that can reduce the emissions with the farming system.
And current figures then for our emissions, it's expressed in terms of total emissions as we've looked at. But if we look at milk specifically, in terms of a kilo of milk, what is the figure?
Previously, the number quoted for Ireland in terms of carbon footprint of milk would be 1.12 kilos of CO2 equivalent per kilo of fat and protein corrected milk. Recently, though, there has been an on-stream of new research through Teagasc to make that value more representative of the grass-based systems within Ireland. So improve the accuracy of the model. And that's done through using Irish research. So for example, previously we didn't have any research to distinguish the difference in emissions from can-based fertilizers, urea or protected urea. However, through Teagasc, we now have that data available to us, and these new country-specific emission factors have been implemented in national inventory, but it's also implemented in our research life cycle assessment models. Similarly then for manure grass, similar process. Before we would have used international standardized values for cattle, not representative of grass-based systems, because then the values would have been derived from studies around the world. So through Teagasc research, we were able to create our own values, and that's now implemented too. And from that, implementing our own values, as well as improved efficiencies, let's say, of the production of fertilizer. There's more renewable energy on our electricity grid. What we see is that 1.12 is now at 1. So it's 1 kilos of CO2 equivalent per kilo of fat and protein corrected milk.
And looking to that figure of 1, is there potential to decrease that? And if yes, what are the methods that you're going to see at farm level in terms of technology adoptions to achieve it?
Yeah, so that's the average. So the 1 kilo CO2 per kilo fat and protein corrected milk is average. Areas what we can do to improve it. First of all, we could look at the fertiliser. So we could capitalise on these new emission factors that have been derived for Ireland. So agricultural systems in Ireland are predominantly can-based systems, and can has higher greenhouse gas emissions than urea and protected urea. So moving from a can-based to protected urea will substantially reduce your emissions. So on average, 80% of fertilisers in the form of can. If you go to 100% protected urea, you're going to get a 7 to 8% reduction straight away, and you're no reduction in fertiliser application rate. Second technology that's available to us that will help to reduce this value further, as well as total emissions, would be the likes of the incorporation of white clover into swards. So by incorporating white clover into swards, you are reducing your reliance on synthetic fertilisers, which is a large contributor to our emissions. And other technology would be like your low emission slurry spreading. So how that benefits is that there's a higher fertiliser value associated with the manure from low emission slurry spreading, and therefore should transfer over in terms of fertiliser requirements on your system. In terms of breeding, improving the fertility performance of your herd will reduce the number of young stock that you require on farm. So as long as those young stock are on farm and they're eating grass, they're going to generate emissions, but you're actually not getting any output from them. So the less a young stock you have, the lower emissions associated with them will contribute. The other thing then too, the more mature your herd, the more milk solids you're also going to get out, the more efficient animal.
To the topic of carbon sequestration, Jonathan, can you give us some information on it? It's something that's thrown about as a topic. It's something that is potentially going to offset against this value of greenhouse gas emissions. But what exactly is it?
Yeah, so carbon sequestration, put it, I suppose, as simply, is carbon that's being brought into grasslands, being brought into scrub areas and hedgerows through photosynthesis. And is being basically stored within the soil or the plant structure for a long period of time. So you're basically taking carbon from the atmosphere and storing it within the earth, whether through ground or through scrub or whatnot.
This currently isn't being included in the inventory. Why not?
No, not in terms of grasslands and hedgerows and whatnot. It's not included in the inventory. And the reason behind that is the research isn't there yet for us to quantify how much carbon is being sequestered per hectare per 100 metres of hedgerow. However, saying that, there is research on the way at the moment that is measuring the carbon sequestration rate from grasslands and also looking at the effect of different management practices. And that's done through eddy covariant towers. So it measures the CO2 coming into the soil, and it also measures the CO2 leaving the soil. And whatever the difference is, that's how much carbon is being saved within the ground. Similarly then with hedgerows, they're using LiDAR technology to calculate the density of the hedgerows. And from there, they're able to see the change in carbon stock within hedgerows on the farm.
So at this stage, we can't quantify exactly what level of carbon sequestration there is. But from your perspective, what are the key practices on farms that would lead to a farm that has a higher level of sequestration?
Yeah, so good grassland management, the establishment of hedgerows and the maintenance of hedgerows are two methods for increasing carbon sequestration. Soil type has an impact on carbon sequestration. Building up the organic matter has been linked to carbon sequestration. They're kind of factors that need to be addressed if you want to improve this carbon sequestration, as well as plant and forestry as well. And
finally, Jonathan, I mean, taking into account what you've mentioned, 12% of the national emissions is coming from the dairy sector. You have armed us with several strategies, and we've heard them here before on the Dairy Edge in terms of, looking at improved fertiliser management, improved animal performance. And this will lead to a lower level of milk output per kilo of milk produced. But invariably, when you point out that an efficiency is improved performance, does that mean the total emissions output is still going to be at the same level if we're seeing cows improving their milk production?
If we do want to maintain our national herd, or a slight increase in our national herd, we will require to have strong implementation of the available mitigation strategies available to us to see both a reduction in emission intensity of milk, but also emissions per farm and at a national level. You know, implementation strategies, as I said previously, in terms of technologies such as low emission slurry spreading, your protected urea, using the EBI to improve the efficiency of your cows, and better grassland management. There are key areas to try to reduce the intensity of the milk, and through that you can reduce your total emissions.
And to follow on, is a stable herd number in terms of the national herd, or an increase in the national herd, is that underpinned by these strategies being implemented wide spectrum, or are we going to need new strategies to achieve this?
If the national herd remains static and we implement the available mitigation strategies that are available to us, so your low emission slurry spreading, protected urea, white clover, better grassland management and EBI, we can see a reduction in emissions per kilo output, but we'll also see a reduction in total agricultural greenhouse gas emissions.
And I think this has been a useful conversation, Jonathan, to really focus our minds from a greenhouse gas emissions perspective in terms of what we're doing on our farms. And if I could take one figure that you've given us today, it's in relation to fertiliser. And you mentioned CAN, and it's a very popular product on farms. So for any of the farmers who are listening in today, there is extensive research where you're switching from CAN to protected urea. You know, there's no implications for grass production, but the figure you've given us today, Jonathan, is a 7 to 8% reduction in greenhouse gases, which is massive and huge implications on an individual farm basis, but also nationally. Thank you, Jonathan. That's it for this week's episode of the Dairy Edge podcast, and my thanks to Jonathan Herron for joining me on this week's show. Don't forget to rate, review and subscribe to the podcast. You can listen on Apple and Google Podcasts as well as Spotify. And for more information, go to the Teagasc website at teagasc.ie. I'm Emma-Louise Coffey, and join me next time for your Dairy Edge.